For a hypothesis test, this problem is very much like the previous one, but now this time we're not looking for a confidence interval, but rather for a hypothesis test. So here, a random selection of volunteers at a research institute has been exposed to a typical cold virus. After they started to have cold symptoms, 15 of them were given multivitamins daily, which contain 1 gram of vitamin C and various other vitamins and minerals. The remaining 15 were given tablets only containing 4 grams of vitamin C. So we have basically a multivitamin, and we have vitamin C. Okay, these are our two groups. Now, the amount of each of those things doesn't matter. You have to look at the problem and see what things are actually important to your calculations. Our N1 is 15, N2 is 15, but the other numbers so far given are not of any great value to you. Okay? It is known that the population standard deviation of recovery time from cold is 1.8 days when treated with multivitamin, and the population standard deviation of recovery time from cold is 1.5 days when treated with vitamin C. Now, since you know that the population standard deviation, right here, it is known. Since it is known, you can use a z-test. Okay? Oops, I'm not writing very clearly. The reason you can use the z-test is because it is you can know the standard deviations of the population. Otherwise, these samples are too small to use the z-test. Okay? If you don't know your population standard deviations, then you would have to have used the t-test. Okay? It is also known that both populations are normally distributed. The researchers claim that the mean recovery time, mu1, of the patients treated with multivitamin is less than or equal to the mean recovery time of mu2. Okay, at the 0.05 significance level, is there enough evidence to reject this claim? So we're going to be pulling up the 0.05 significance level. Our null hypothesis is going to be that mu1 is less than or equal to mu2, and that'll be very important. Okay, so our claim is that the mean recovery time of the multivitamin group is less than or equal to the mean recovery time of the vitamin C group. So HO is going to be that the mu of the multis is less than or equal to the mu of the vitamin C, or mu1 less than or equal to mu2. Okay? Therefore, the alternative will be yes, Amy, you do have to use, well, you should use the z-test. Now, the t-test is would give you a much broader confidence interval, so it's harder to reject the null with a t-test than it is with a z-test. Since you know more information, the z is essentially more accurate. Okay, it's more, it gives you a tighter result, so z is preferable to t. Okay, and indeed, when you're working with a program like this, the program has as its correct answer the result from a z-test, not from a t-test. So you definitely want to get it right on the ALEKS, and so you want to use the z-test. Okay. So since we're given the standard deviations, we use the z-test. And here is z. Remember, from the difference of the means, we are going to use this standard deviation. It's the same as what we used for the margin of error. And for the numerator, it's just the difference of the sample means minus the difference of the population means. Okay, now this is essentially the same formula as what we used for the original z-score. Now the z was x bar minus mu over the standard deviation, but the difference here is that the difference of the sample means minus the difference of the population means, instead of just the sample, an individual sample mean minus an individual population mean. So our problems have become much larger. This is a kind of long and complicated calculation, okay? And the standard deviation formula, of course, is from the difference of the mean. This is the one we just used a minute ago. So the margin of error is our z times that same standard deviation over the square root of n. Do I feel like I left out a calculation? Well, I seem to have left out a pretty good significant chunk of this right here. So to calculate the difference of the sample means, our original problem gives us all of the data. So we will load this data into the ALEKS calculator. Let me see if I can find it. I was thinking this problem didn't look completely finished. It's because I didn't finish it in my work today. All right, so if we load this data, now this is actually a PowerPoint slide, so it's not going to load in there automatically for me, but I can load data by just typing the numbers, 6, 5.9, 8 point, what did I do? 6, 5.9, 8.8, 6 points. Now if you just highlight this whole list of data, comma, okay, so if you just highlight the data, and ALEKS calculator will pop up for you. My problem is that in order for me to do these problems and actually be able to write on this, I have to have a picture of it in PowerPoint, and then I can't actually dump it into the calculator, which I usually do beforehand. All right, so notice earlier when you used the calculator, you did not have these two keys, the X bar and the S. I'm going to make my window a little tighter. I'm going to show you this ALEKS calculator here, bigger. So you now have an X bar and an S. So the mean, the sample mean, and the sample standard deviation are here for you, okay? So if I do that now, my sample mean is 6.16, and then I can do the same thing with the other set of data to get that sample mean, okay? Then, if I subtract those two values, move my window back. If I subtract the means of the two groups, then I will get the standard deviation of all of that worked out from that big formula is 40. From all of this, I put in the numbers that were given. So you notice your standard deviation was given 1.8, and the other one is 1.5. Okay? So you plug all of those in, and I thought that I had a nice one at a time explanation for it, but I don't seem to have included that. Divided by the square root of your sample size, and gives you an error. You know what? Oh goodness, folks. I have jumped all the way from one problem to another. I'm not completely sure what happened here, because my N is only 15. And I have another whole problem here. Please forgive me. Before I post it, I'll get that corrected for you. All right, let's skip to another problem because I can't make that one work right. Do you see what needs to happen to it? Just use the formula. Just use the formula here, plug in all the appropriate numbers, and then that is your z-test. That is your z-score, which you will then compare to your test statistic. Now, what was our test statistic? What's our what is our significance level? Significance level is 0.05. And what direction is this test? It is a right-tailed test because the null is less than or equal to, makes the alternative greater than. So at the 0.05, so I can use the calculator to find z of 0.05 is 1.645, and that's what I'm going to compare my final z-score to once I work that all out. Okay?